I'm an application support specialist at Blue Marble Geographics, and today we'll be taking a look at swath separation in Global Mapper. Let's start off with a bit of context. This is a Lidar point cloud covering the city of Rutland, Vermont, currently colored by the elevation values from green to red. Turning off the point cloud for a moment, we can take a look at the world imagery underneath and see that this point cloud covers the major roads and the downtown area of Rutland with mixed building and trees. I'm going to turn back on the point cloud and return to that. Now, zooming in with the 3D viewer, we can get a good sense of how the point cloud really looks and what its dimensions look like. We can see that there are buildings kind of floating above the surface as rooftops because we don't have perfect building walls in the point cloud. Then we could change the visualization of the LiDAR to point source ID, which tells us exactly which swaths or strips or flight patterns the LiDAR points belong to. And we can see that there are several in this particular point cloud with a good deal of overlap. Getting a quick sense for the data, we can draw a path profile and see that the swaths meet up a bit messily in some places. Now, to provide some quality assurance, we're going to use the swath separation tool, which is accessed from this icon of the LiDAR toolbar. There are a few different options that you can specify, and the first is the spatial resolution of the output image that you're going to create. You can choose point spacings or meters or feet, and if you choose point spacings, it'll be a little bit more context specific to the point cloud. Meters or feet, of course, a little bit more of an absolute value for the reference unit. As for the grid method, the automatic or the default choice is triangulation with a grid tin of the points. That can be a little bit messy when you're dealing with a particularly complex or dense point cloud, which I think this cloud is relatively dense. So perhaps binning with the average value would be a good alternative. Of the returns, you can filter to just the single returns or the last returns. In this particular instance, I'm just going to leave it with all returns so that we're using all of the points in the point cloud. There's also a bounds option where you can limit the size of the image that you're creating with swath separation. And we have some baked-in options for the swath overlap shader. There's QL0, which is for a smaller amount of difference in elevation between neighboring swaths from 0 centimeters to 8 centimeters. And then there's QL1, QL2 for a little bit more difference from 0 to 16 centimeters. And that's the one I'll use here because these adjacent swaths have a decent degree of separation, of difference in the vertical elevation. Checking the option to save the SSI grid, I'll name my output swath separation.tiff, and I will run the tool. It'll take a minute to run, and once it has finished running, it'll create two layers. One of them, the swath separation TIFF, and then one of them, that SSI swath separation image grid overlap difference layer. Taking a look first at the swath separation output, now that it's finished running, we can see in green and in red the areas with less and with more difference between the overlapping flight swaths. Rooftops are relatively stable because they are coming across as the same elevations in different swaths, but the vegetation and trees are likely to be a little bit higher of a difference between, just because they're prone to movement and they're less geometrically regular, and so they come off a little less predictable. We also see in the background the intensity values of the point cloud in gray. As an alternative, the SSI grid overlap difference layer is a little bit more of a clear paletted version from green to red of the difference between the overlapping swaths. And you can enable or disable the hill shading to sort of show the differences in elevation with a little bit of shading, or to leave them just as the flat colors that they are in the raster. And we can see here that the edges of the buildings tend to be redder, darker. That's because the adjacent swaths tend to have a little bit more disagreement at the edges of buildings, depending on the angle that they're looking at the buildings from. So now to zero in on a few different examples of this in action, we could look closely at this particular area in central Rutland, where there are a few buildings with these red edges that suggest a relatively high disagreement in the elevation between the adjacent flight swaths. And drawing a path profile across a few of these buildings diagonally, we can see that some of the buildings only have a building side in one of the swaths and not in the other one. And that can contribute to the difference between the elevations that are being reported from one swath versus the next. And that's helpful to know for a quality assurance kind of look at your LiDAR point cloud. For another example, we could turn to this long building in the southwest of Rutland. It's near the train station. If we turn on the world imagery for a second, we can see it's right by the railroad. And it's also happens to be at the intersection of a couple different swaths of the point cloud. So drawing a path profile across this particular building, we see a very distinct example of one side of the building coming up in one swath, the other in another swath, and then the dominant swath on the top of the building is yet a third swath. And we can see that that comes across in the SSI grid overlap difference layer as a high amount of difference between the adjacent swaths in that place. As you can see, that building is surrounded by a relatively dark red outline. And just for a third and final example here, we could look across a street at the buildings on one side and the buildings on another, and note that the facades on the west side of the street are being detected in the swath that's in blue, and then the other side of the street is coming across in that darker greenish blue. And that results in a difference at that local place between the elevation that one swath would conclude that place is at versus that the other swath would lead you to believe. Now, this is a very dense and highly overlapping point cloud, but just to take a quick look at one where there's not quite so much overlap as this, you can see here that there's no place where there's only one flight swath. An alternative example here, you can see swaths that are partially overlapping but not fully overlapping. And in that instance, you would see an output layer with separate strips of imagery. So that's a little bit of a primer on how to use the swath separation tool for quality assurance of your LiDAR data. If you have any questions, you can reach us at our website, or you can contact us at geohelp@bluemarblegeo.com. Thanks for watching.